Section 11.5, Solving Equations with the Multiplication Property. This section is similar to 11.4. The idea remains the same. We want to isolate the variable all by itself on one side of the equation. The way to isolate the variable is to undo the shown operation. So let's say that you were given the problem 5x is equal to 20. Remember, 5x means 5 multiplied by x. So we are going to do the opposite of multiplication. We are going to do division. We are going to divide both sides by 5. If I divide the left-hand side by 5, the 5 divided by 5 cancels. I'm just left with the x. But if I divide the left side by 5, I have to divide the right side by 5. 20 divided by 5 gives me 4, so the final answer to this is x is equal to 4. Let's do one, but it starts off where I am dividing. It says x divided by 3 equals 9. Once again, I want to undo the shown operation, which is division. And the opposite of division is multiplication. So this time, what I'm going to do is I'm going to multiply that left-hand side by 3, because in the original problem it was x divided by 3. If I have to do that on the left-hand side, I'm going to have to multiply the right-hand side by 3. Now, what I have here is I have a fraction 3 over 1 times x over 3. The 3's just cancel, and I am left with x on the left-hand side. 9 times 3 gives me 27. So the final answer to this is x is equal to 27. Let's look at another example. Here I have negative 7x is equal to 35. I have negative 7 multiplied by x. So in order to get rid of that multiplication of negative 7, I have to divide both sides by a negative 7. The negative 7 divided by negative 7 on the left-hand side, the negative 7's cancel, just leaving me with x. And on the right-hand side, 35 divided by negative 7 gives me 5. So the answer to this is x is equal to negative 5. Let's take a look at one that starts off division and once again has some negative values in it. X divided by negative 8 is equal to negative 3. I want to get that x all by itself. So what I'm going to do is I am going to multiply that right-hand side by a negative 8. So I have negative 8 negative 8 times x over negative 8. I'm going to have to multiply the right-hand side also times a negative 8. Once again, on the left-hand side, I have negative 8 times x over negative 8, and I could think about that as negative 8 over 1. And the negative 8's cancel, just leaving me with x. And on the right-hand side, negative 3 times negative 8 gives me a positive 24. So the answer to this is just x is equal to 24. Let me do one more, and this is one just to be very cautious with. I have negative x is equal to negative 12 as the problem. So this is saying the opposite of x is equal to negative 12. Remember, you need to solve this for x. There's an understood 1 in front of that x, so it's really negative 1 times x. So if I want to solve that just for x, I'm going to have to divide both sides by a negative 1. When I do that, the negative 1 and the negative 1 on the left-hand side cancel. I'm just left with x. On the right-hand side, negative 12 divided by negative 1 gives me 12. So the answer is x is equal to 12. And when you think about it, remember, this was the original problem. The opposite of x is equal to negative 12. Well, if the opposite of x is equal to negative 12, then x would have to be equal to 12. And you could use that logic as well, but if you want to show it algebraically, what I did right here shows what you are doing algebraically to get that answer. In this section, we also need to deal with fractions and decimals when we are multiplying. So here I have 2/3 x is equal to 6. Now there are all sorts of different ways of doing this. It says 2/3 times x, so one thing I could do is I could divide both sides by a negative 2/3, but I want to talk about probably an easier way of doing this. You know, this has fractions, and most people do not like fractions. So what I say, the very first thing to do is get rid of the fractions. And the way to get rid of the fractions is to take a look at the denominator. The denominator is 3. If I were to go through and multiply both sides by the denominator, I would get rid of that fraction. So I'm going to say that the least common multiple of my denominator, known as the LCD, the least common denominator, is equal to 3. And what I'm going to do is I'm going to multiply both sides by 3. Notice what happens when I do that. I have 3 times 2/3 x is equal to 6 times 3. Now remember that 3 is really 3 over 1. And now I can go through and I can cancel. The 3 and the 3 cancel. It just leaves me with 2x. And I have 2x is equal to 18. At this point now I can just divide like normal. I'm going to divide both sides by 2, and I'm going to get a final answer of x is equal to 9. There are all sorts of different ways of doing this problem, but I find a lot of people have success if they just do it in a few steps. Let's take a look at another one. I have 3x over 2 is equal to 8. Once again, this has a fraction, and we don't like fractions. So the least common denominator, and I keep talking about that because later on that will become important, but the only denominator I have is 2, so the least common denominator is 2. I'm going to multiply both sides by 2. So on the left-hand side, I have 2 times 3x over 2. On the right-hand side, I have 8 times 2. Now, on that left-hand side, that 2 is 2 over 1, and I'm multiplying, which means the 2's get canceled. I'm just left with 3x is equal to 16. Now, I would divide both sides by 3, and I would get x is equal to 16/3. 16/3 is an improper fraction. I could change that by dividing 3 into 16. If I change that, 3 goes into 16 5 times. 3 times 5 is 15, so I get 5 1/3. So x is equal to 5 1/3, or if I wanted to write it as a decimal, I could say 5.3 with the 3 repeating. Let's do one more example. 4/5 x is equal to 10. The least common denominator is 5. So I am going to multiply both sides by 5. So I have 5 times 4/5 x is equal to 10 times 5. That 5 on the left-hand side is 5 over 1. When I multiply, the 5's are going to cancel. I'm going to be left with 4x is equal to 50. So then I'm going to divide both sides by 4. If I divide both sides by 4, I'm left with x is equal to 50/4, which can be put down into lower terms. If I want to do it that way, I could divide by 2 over 2 and get 25/2. I can't leave it 25/2, so I need to go through and do a little bit of division here, and I'm just going to do that fairly quickly, as you can see. When I do that, I am going to get 12 1/2 for an answer, so I could either write 12 1/2, or if I wanted to, I could write 12.5. I mentioned that in this section you might also have to deal with decimals. So here I have a problem, 1.3x plus 2.8x equals 12.3. The very first thing to do is to combine like terms if possible. So I can add that 1.3 and 2.8 because they are both with x's, and when I do that I get 4.1. So what I have is I have 4.1x is equal to 12.3. I'm going to do the same thing as if that was a whole number. I'm just going to divide both sides by that 4.1. The 4.1x over 4.1, the 4.1's cancel out, I'm left with x. And then if you go through and divide 12.3 divided by 4.1, you are going to see that you have an answer of 3 for your final answer. Section 11.5 is very similar to section 11.4. You are just undoing the shown operation to get the variable by itself. If there is anything I can do to help as you work through the problems, please let me know. Thank you.